In this video we'll discuss similarity within area and volume. Now when we talk about similarity, we often have to start with the idea of what is similar, and we're looking at the lengths being similar. They have to be proportional by that scale factor. And then what we find with the area is that it's that scale factor squared, because think about it, you have a length and a width now when you're talking about area, and that would mean the scale factor for the length times the scale factor for the width would be the scale factor squared. So say I have an example with these two rectangles and I want to find the area of my large rectangle. I can do it one of two ways. One, I could use the side lengths and use the scale factor to help me find the missing side. So I could do the 3 to 6 is going to equal 5 to the top side, which we'd find out to be 10 inches. Then I can find area by doing length by width. In other words, 60 square inches. The other way would be to use the scale factor and then use that compared for my area. So I know again that scale factor is 2 to 1 for my large rectangle. And I know then that the area ratio of the large to the small would have to be 2 to the 1 squared. In other words, it's 4 times the size of this smaller rectangle. So if I find the area of my small rectangle, which 5 by 3 is 15 square inches, that's very easy, and I multiply it by that scale factor because the area should be 4 times as much, I'll get 60 square inches. So two different ways, I still end up with the same solution. Now say I want to apply this to what could be a more real-world situation. I have a flower bed that had a 4-foot circular and a circular width of 4 feet. So I'm looking at a circle with a diameter of 4 feet, and it's left unattended. The area we recognize then has doubled over the year that it's been unattended, and we will know, well, how wide is this bed now? So what I can use is that scale factor relationship between the widths and the areas. I know that the width for the new bed divided by the width for the old bed squared will equal the ratio of the areas. So I can use the information I have. I know that I don't know my new width, but I know that the old one was 4 feet, and I know the ratio of their areas should be 2 to 1. So if I take the square root of both sides and then multiply by 4, I should get that the width of the new flower bed should be about 4 the square root of 2 feet, or 5 and 66/100 feet. Now that doesn't make sense to some people. They say, well, if my area is doubled, why is my width just barely a little bit larger than the original? So let's check it out. If I think about my old bed, the radius would be 2 feet because it's half the diameter. So the area would have been 2 squared times pi, in other words 4 pi. Now if I look at the radius of the new bed, that's 2 to the square root of 2. That's half of the 4 square root of 2. And I square that and multiply by pi, I end up with 8 pi. So if I look at these two areas, the ratio, area of the new, 8 pi, area of the old, 4 pi. That's double, even though the widths are not double, because you got to remember, the ratio of the length to the width is going to be the scale factor, the areas are going to be the scale factor squared. Now when we talk about volume, we still can use that idea that we start with the scale factor of the sides, and then the volume will be proportional by the scale factor cubed. Because you think about it, you have a length, a width, and a height, so that's scale factor times scale factor times scale factor cubed. So say I have this problem here and I want to know, are the prisms similar to one another? Well, I'll do the scale factor of the lengths. So that's 3 to 1. If I look at the 15 compared to the 5, that's a 3 to 1 ratio. And if I want to look at the 9 compared to the 3, that again is a 3 to 1 ratio. So I could say that these two prisms are similar to one another. Now say like the last problem, I have a missing side in this case on the small rectangular prism, and I want to find, well, what's the volume of it? Like the last time, I could do it two ways. I could just find the volume of the small prism using the scale factor. I could say 15 to 5 should equal 12 to this missing side, which would be 4 feet. So then find the volume of the prism, I do length times width times height, and I get that it would be 60 cubic feet. The other way would be to use just the similar volumes with the scale factor. I know that scale factor of the small compared to the large would be 5 to 15 or 3 to 9, whichever you want to use, but that's 1/3 for the lengths. To find the scale factor for the volumes, it's that 1/3 cubed. So 1 times 1 times 1 is 1, 3 times 3 times 3 is 27. So if I find the volume of my large cube and multiply it by the scale factor, I'll find the volume of my small cube. So the volume of the large cube, 12 by 15 by 9, is 1,620 cubic feet. Then if I multiply it by that scale factor, I would end up with 60 cubic feet. Again, two different methods, I still get the same volume.